Hello everyone. I hope you can hear me. So, so today is our fourth day of live coding. In this session, we will see some of the text pre-processing techniques. Okay. So, uh, so for this topic comes under natural language processing. So, let's look some of the uh, pre-processing techniques we do before applying any models on our text data. Okay. So what will be the topics covered in this session will be first will be the problem statement. Means we will take one problem and we will use that. Then we will import libraries. Then we describe our data. Then we will do text processing. Okay. In text processing, we will do lower casing, word tokenization, stop words removal. Then we will do stemming and lemmatization. Both try to convert stemming and lemmatization. Both try to convert words in their base form, but there is some difference, minor difference. So we will look at that. Then we will see part of speech tagging. Then we will see named entity recognition. Means is that word related to place or person or any other thing. Okay, and then we will conclude. Okay, so let's start. Uh, we will start with problem statement to apply several text processing techniques on text corpus. Okay, so we will apply several text processing techniques on text corpus in order to use ML techniques on text data. We need to convert text data to numerical values. Okay, so if we want to apply any ML technique on text data, so any model will take numerical data only. For that, we need to apply various text processing techniques. So, before converting our text data to numerical form, we need to apply various text processing techniques. Okay, so process your text simply means to bring your text in a form that is predictable and analyzable for your task. Okay. So for this, first we import libraries. So we are importing NLTK. NLTK is one library which is most commonly used for text processing. Okay, and then from nltk.corpus we import brown. Okay, then from NLTK we import word tokenize. Then from nltk.corpus we import stop words. Means these stop words have all the stop words. Then from nltk we import sentence uh, tokenize. Okay. Then from nltk dot stem we uh, import wordnet lemmatizer. Okay, this is the one particular type of lemmatizer, wordnet. Okay, and then from nltk.stem we import snow snowball stemmer. Okay, so this is lemmatizer wordnet and snowball it is stemmer. Then in the last we are importing from nltk we are importing frequency distribu distribution. Okay. So these are the libraries which we will use in our task. So let's run this. Now Uh, Now, what we are doing, we are importing all the warnings, and then warnings dot filter warnings action ignore. This is used to suppress our warnings. Okay. So after that, from NLTK, we will download some required, you can say, things like Puncti, stopwords, WordNet, Max Chunker, then words and average perceptron tagger. Okay, so we will download these things. Okay, now come the data set description. Okay, so for our task, we will be using brown corpora. Okay, so the corpus consists of 1 million words of American English text printed in 1961. So this corpus have 1 million words of American English. Okay, this corpus contains text from 500 sources, and the sources have been categorized by uh, genre. Sorry, and categories are genres such as news, editorial, and so on. So you can see we have news, editorial, and reviews, religion, hobbies, and other genre are there. Okay. Now come the first question. Uh, how can we download the brown corpus using NLTK? Okay, so to download the brown corpus, we can mention like NLTK dot download and brown. Okay, so let's run this. Okay, and you can see hint also. We use NLTK dot download to download any corpus, and then we are downloading brown corpus, so we will mention brown here. Okay, and then we will run this function download brown. After this, we are printing categories in our text corpus. Okay, so def print brown categories. So brown dot categories, run this. Then if we see what are the categories in our brown corpus, so see adventure, um, editorial, fiction, government, hobbies, humor, hu- uh, learn, and different categories are there. Now come the text preprocessing. We know that in order to deal with textual data with machine learning, we need to convert it to numeric form. In our previous sessions also, we have seen that we need to convert our data into numeric form. But before applying embedding to apply text to numeric form, text data should be clean and reprocessed. So before applying techniques, we need to do cleaning of our text data. These things we do generally when we applying machine learning or deep learning. But in case of like LLMs and sequence to sequence models, we don't do. this text pre-processing. Okay, the pre-processing steps for a problem depend mainly on the domain and the problem. And what are the pre-processing steps we need to apply? These are mainly depend on domain and the problem. Okay, the various text processing steps. So, what are the text processing steps? First is lowercase in text. Okay, so we will convert our complete text to lowercase. Okay, then we do tokenization. We split our text into tokens. Then we remove punctuations from our text. Okay, so we can see that punctuation. Okay, so these are the punctuations, punctuations in English. Question mark and other like question mark, asterisk, parenthesis, and these are the punctuations at the rate, sign, braces, and all these. Okay, so we remove punctuations. Then removal of stop words. So we remove stop words. So stop words like words which are commonly used like the, is, he. Okay, so these are the stop words in English. A, I, the, in, of, for, at, which are commonly used. Okay, so we will remove those stop words also. Then removal of frequent words. Uh, Which sometimes is depend on our use case also. So if any word is coming very frequently, we will remove that. But it depends. Okay. Then come the stemming. Then lemmatization, removal of emojis if any emoji is there. Then conversion of image emojis to words. Removal of URLs if URLs are there in our data. And then spelling correction. Okay. So let's start with uh, lowercase m first. 1 second, guys. Just a second. Just a second. Okay. So we will start with lowercase. Okay. So for example, it is mentioned like insert, and insert. So these are the same words. But you can see due to here all characters are in uppercase. Here first character is in uppercase I, and in the last all are in lowercase. So these becomes three different words. So it is unnecessarily increasing our vocabulary. So what we will do, we will like convert all these words into lowercase or in uppercase. So but without lowercase, we need three word vector to represent them in vector space. It will also help in reducing size of text data vocabulary. So we will see one example like text. The capital of India is New Delhi. So this is one text example. Now we convert our text to lowercase. So we can use dot lower here, one Python function. So lower text, text dot lower. Okay. So if we will run this and we will run this function to lower and provide our text here and save the result in lower text. So run this. Now, if we will print lower text, you can see the capital of India is New Delhi. Okay, so I hope it is clear now. Second, come the word tokenization. Tokenization is the process of splitting the given text into smaller pieces called tokens. Okay, so uh, word num word, numbers, punctuation marks, and others can be considered as tokens. So, word, numbers, punctuation marks, and everything can be considered as tokens. For example, if input sentence is International School of AI and Data Science. So, after tokenization, output will be International School of AI and Data Science. Okay. So, means on the basis of space, they are tokenizing here. Okay. So again, we take the same text. The capital of India is New Delhi. To perform, how to perform word tokenization on a sentence. So, we have imported word tokenizer from NLP. You can see word tokenizer. So we will use word tokenize only here this time. Okay. So nlpk dot word tokenize and then text. Okay. And then return word token. So run this and if we will run this function tokenize function on text and save the output in word tokens. Okay. So it is giving one error punct tab not found. Please use the NLTK downloader to obtain the resources. So Fun tab is not downloaded. Okay. So it is also mentioned we need to download Fun tab. Here we download Funky, but we need to download Fun tab also. Okay. So we will do here NLTK dot download Fun tab. Let's run this. Okay. Now that error will not come. Okay. It runs now. Now let's see word tokens. Okay. So you can see the capital of India is New Delhi and punctuation is also considered as separate tokens. So these are the tokens. Okay. So next is it is the text which has two sentences. Which you can say that it is a small paragraph. The capital of India is uh, New Delhi. Okay, and the capital of China is Beijing. So this is the text which we can consider as short paragraph. It has two sentences. What if we want to tokenize sentences from paragraph? So previously we have tokenized words. Now we want to tokenize sentences. So from NLTK we have imported word tokenizer and sentence tokenizer. Okay. So we will use a sentence tokenize. Okay. So we will define function tokenize function text. So we will mention NLTK dot send tokenize, sorry, and then text and return this send token. Okay. So if we will run this function tokenize function on our text and save the output and send tokens. Okay. So now you will see that both sentences are converted into this is first token and this is second token. Okay. So now come the now come the stop words removal. Stop words are a set of commonly used words in any language. So what are the stop words? These are the commonly used words in any language. Stop words usually don't provide valuable information for analysis. So why we generally remove stop words? Because they don't provide valuable information for analysis. The intuition behind not using stop words is that by removing low information words from text, we can focus on the important words instead. So the intuition here is if we will remove low information text, then we can focus more on important words. Okay, so in English, words like I, is, was, because, him are considered as stop words. For example, if our input sentence is CEO is a cool guy, okay, the out then output after removing stop words will be CEO cool guy. So here you can see if we are doing a sentiment analysis, uh, or you can say is this a positive feedback or negative? So is or A are not contributing too much in our sentiment. Okay, but cool, that word cool is saying like it is positive feedback. So that's why we remove strong word. So we will see list of stop words in English language. So dot join stop words. Uh, these stop words we have removed. We have downloaded from NLTK. Stop words dot words English. So these are the stop words in English. So now we remove these in one variable name at stop word. Okay. So the capital of India is New Delhi. Again, same time. So word tokens NLTK dot word tokenize and then text and print word token. Okay. So we have converted our uh, text into tokens, our sentence into tokens. Now, how to remove stop words from text? Okay. So we will define one function, stop word removal, and then we provide word tokens in that, and then we will write code to remove stop words. So let's check the hints here. Uh, So it is saying that use a list comprehension for removal of words from word tokens that are not in stock word list. Okay, so here we have created the list of stock words. Okay, means we have stored all the stock words in a stock word. So we will do list comprehension word. So we will do list comprehension here word for word in word token. If not in stock stock word. Okay, like this we will do. There is there will be some error. Let's see what will come. Okay, so it is showing syntax is invalid. So if here we need to mention word, what is not in stock word. So for word not in stock word. Okay, so word for word in word tokens is word not in stock word. So we will run this. We will run now. Okay, so this is the function. It will remove this output. Now run this function on word tokens and save the output in removing stop words. Now print removing stop words here. So you can see the capital India, New Delhi. Okay. So off is removed, is removed. So like this it works. So we have removed stop words also. So now come the stemming. So what is stemming? Stemming is the process of getting the root form of a word. So stem by using stemming, we can get the root form of a word. In stemming, we chops off end of words to get their root form. So we like remove end of words to get their root form. A root form can or cannot be a real word. So it may happen that root form which is coming after stemming is not a real word, and not, or you can say correct. Stemming is useful for dealing with sparsity issue as well as standardizing vocabulary. So like playing, played, plays are there. So sparsity is there. So we use stemming in that case. So, for example, words like connect, connects, connected, connections, connection will be converted to connect. Okay. So, so this is the stemming. And now we are using here a snowball stemmer. So we are creating one object, snowball stemmer, which contains snowball stemmer for English. Okay. So this now text the athletes are running faster. Okay, run this. Now word token NLTK.word tokenize text. Okay. Now comes our question: how to perform stemming on a given corpus. So for this, uh, a snowball stammer dot stem. Try to solve this. Snowball stammer dot stem. Okay, and then we provide word tokens. So let's see it will work or not. Stemming word, stemming function on word token. Uh, so it is saying that list object has no attribute lower. So snowball stemmer dot stem. Okay, I think we need to uh, we need to use list comprehension here. Okay, let's do in that way also. I'm just checking word for word in word tokens. Uh, okay, and also I am not applying lower here. Let's see, or we need to apply. Sorry, here lower we need to apply or not. Okay, we don't need to apply lower here. If we remove stem, so you can see it is mentioning the athlete are running is become run. Okay, the athlete and athletes are become athlete. So athletes are become athlete and uh, running becomes run. Okay, so that is stemming. Here error was coming because we are providing complete sentence to stemmer. I think we need to provide word here. Okay. Now come the lemmatization. Actually, it is advanced form of this, and it is better in terms of accuracy. So, lemmatization process also lemmatization process also converts words to their reduced form. Okay. But unlike stemming, lemmatization converts words to pre-existing words in any language. So when we are doing stemming, it is not necessary that a and word will be exist. Okay. But in lemmatization, it makes sure that the word it is converting is a pre-existing word. Okay. So converted words, root words are called lemma, and the root word is generally known as lemma. For example, words troubles, troubling, troubled, trouble can be reduced to word trouble. Okay. So if we are here is one example. If we are converting interchange, interchanger, interchangeable, interchanging. So it will be converted to interchange. So E is not there. It is not correct word. But with lemmatization, it makes sure that word already exists in dictionary. Okay, so it will convert correctly. Lemmatizer. So from NLTK, we will download WordNet. Okay, so let's see what is this WordNet. Okay, so we can Google this, so, or we can say what is WordNet. Okay, WordNet is a massive publicly available lexical database for English language. It groups word into set of synonyms called syntax, provide for definitions and maps out semantic relationship like general to specific concept and opposite. Essentially, func- functioning as a advanced concept-based combination of dictionary and a research of AI and linguistics. Okay. So WordNet, what is WordNet? WordNet is a massive publicly available lexical database for English language. Okay. So we have downloaded WordNet from NLTK. Then the athletes are running faster. Here, see, for athletes, it converted to athlete. Okay, so this is not the correct spelling. But here, when we are using lemmatizer, so we will use WordNet lemmatizer here. So WordNet lemmatizer and save this in object WordNet lemmatizer. Now, uh, word tokens NLTK dot word tokenize and then text and save it into word tokens. Now, word tokens, we will see. So these are the tokens. So how to perform a lemmatization on word corpus. So we will write down function here. So we will define one function, a lemmatization function, and as an input, we will provide word tokens here. Okay. So lemmatized word. Write code for performing lemmatization here. Okay. So I think here also we will use dictionary comprehension. So, word, let's take the hand first. Okay. Previously we have used dot stem. Here we will use dot lemmatize. Okay. So word tokens dot lemmatize lemmatize word for word in word tokens. Okay, like this we will do word tokens uh, and it will be word net lemmatizer or word token. Word net lemmatizer dot lemmatize word for word in word tokens. Okay, run this and then run this function and save the output in lemmatized word. Okay, now print the lemmatized word. The athlete are running faster. It has not converted running into its base form. I don't know why, but yeah, this is what lemmatization did. It has not converted running into its lower form. Okay, now uh, we will take next text. Twinkle, twinkle, little star, how I wonder what you are. It is one famous poem, and then we convert them into tokens. NLTK dot word tokenize. Then, or before doing that, we convert this into lowercase text dot lower and save output in word tokens. So let's run this. Now we will print word tokens twinkle, comma, a little, uh, then star, then again comma, how I wonder what you are, then full stop. So how to calculate the word frequency of each word in the text and print the and most common word. Okay, so so now we will see how we can calculate the word frequency of each word in the text and print the and most common words. So we will define one function, word frequency function. 1 second, guys. Just a second. Okay, so YouTube. Okay, so now I think it will be working fine. Okay. So then what we will do, we will define function word frequency function, and it will take word tokens as input. Okay. Now here write code to calculate the frequency distribution of words here. So let's see think here first. We will use frequency distribution from NLTK on word tokens variable. Use the frequency dot most common function with n equal to 5 as parameters. Okay. So we have you remember that we have imported frequency distribution. So what we will do, frequency distribution, then we will provide word tokens. Okay. Uh, right code to and then what we will do, we will use frequency dot most common and n as 5. Okay. So now frequency dot most common, and here we will provide n as 5. So run this. Let's see it will work or not. Then okay, run this. Okay. So you can see comma is coming 3 times, then twinkle 2 times, then a little, star, and how. Okay. So if we want to see three most common, so you can see comma, then twinkle, little. Okay. So what we do to calculate the word frequency, we use frequency this function which we have imported from NLTK, then provide our word tokens in that. And after that, we use dot most common and provide n as 3. Now come part of speech tagging. A part of speech tagging is a process to mark word in a text corpus based on definition as well as in its context and semantic meaning. So what we do in part of speech tagging is we mark word in text corpus based on its definition and text. Okay, and whatever its semantic meaning. And now, part of speech tagging aims to assign parts of speech to each word of a given text. So, it will for every word, it is try to assign part of a speech. Like, is this word a noun or verb or adjective or any other? Okay. For example, sentence the kids are playing in the park. We give output as follows after applying part of speech. The will be the determiner. Okay. Then kids will be the noun plural. Okay. And R will be the R will be the verb present. Okay. So and then playing will be the verb, and ground present participle. Okay, verb. It will be the verb. And then in will be the preposition, subordinate, and method. Okay. The it will be the determiner. Then park will be the noun, singular noun, and then full stop. So these are the part of a speech tag list. See coordinating conjunction, cardinal digit, determiner, preposition, adjective, comparative, adjective, superlative, model, noun, singular, noun, plural, proper noun, proper noun, plural, predeterminer, possessive ending, personal pronoun, possessive pronoun, adverb, adverb comparative, RBS adverb superlative, then RP, sorry, then verb present tense, and like this verb present, verb third person, and determiner. Okay, so these are some part of speech tags. So we will provide like this. If we will get like this or provide like this. Now what we will do, from nltk.download, we will download averaged perceptron tagger. So what is averaged perceptron tagger? The average perceptron tagger is a pre-trained machine learning model in Python's natural language toolkit used for part of speech tagging. Okay, so uh, it is pre-trained machine learning model. It analyzes text and assigns grammatical categories to each word. So this is average perceptron tagger. Okay, so we will download it. Great. Now we have text. The kids are playing in the park. Then we convert our text into tokens using word tokenize. And now comes our question: how to perform a part of speech tagging? Okay, so we will define one function, POS tagging, and then for input the word tokens, and uh, use NLTK dot POS dot underscore tag with word tokens as parameter. Okay, so what we will do, NLTK dot POS tag, and parameter will be word tokens. Okay, so like this, this hint is saying, so if we will run this, okay, this will be our function POS tagging. Now run this function POS tagging on word tokens and save the output in POS part of the speech tag. Okay, wow. It is saying that average perceptron tagger English not found. So this resource is not found. So we need to download this also. Let's see, we have downloaded it before. Okay, we have downloaded it, but I think name has changed or something. So NLTK dot download, and then average perceptron trigger underscore English. So run this. Actually, these two codes are modified and this uh, function underscore tab. Okay. So go down. Now, now run this. Okay, it's run now. Whenever we get any error, we should know how to deal with it. Like when this error was coming, you can see a solution was also mentioned there. Like this is not present. You need to import and then download, import and then download this part. So you should know how to debug any errors. Okay, because I am also doing this code for the first time, and whenever I am getting error, I am trying to resolve that only. So now run this. So this is our output. You can see that wait for one second. Okay, one more question is there. I'll complete that also. Name entity recognition. Okay. Okay. The aim of name entity recognition is to find and classify named entities in text into predefined categories such as names of person, organization, location, expression of times, quantities, monetary values, percentages, etc. So means named entity recognition means if anything is coming, will it related to place, person, organization, or is it the expression of time, or is it showing expressing the quantity, monetary value, percentages, like this. Okay, NER name entity recognition can be useful in applications like classifying content for news providers, uh, summarizing resumes, optimizing search engines, algorithms, and simplifying customer support. Okay, so in those, this NER can be used. Now, this is the text. The New Delhi is the capital of India, and Beijing is the capital of China. So, uh, we will tokenize the input text. Okay, so word tokens NLTK dot word tokenize and then text, then we show the word tokens. So these are the tokens. Now we will apply part of speech tagging NLTK dot POS tag word tokens and then POS tag New Delhi. New Delhi is the capital of India. Okay, so like this we have applied. Now we will implement noun phrase chunking to identify named entities using a regular expression consisting of rules that indicate how sentences should be chunked.